একজন বলো লাস্ট কত অবধি ডিসকাস হয়েছিল?
স্টার জিওমেট্রিক্যাল আইসোমেরিজম অল্প।
জিওমেট্রিক্যাল আইসো দেখেছো ভিডিওটা আগের দিন?
হ্যাঁ স্যার, পুরাটা দেখছি।
আইসোমেরিজম বুঝতে পেরেছো?
হ্যাঁ স্যার।
আচ্ছা, একটা কোয়েশ্চেন আগে অ্যান্সার করো। হ্যাঁ, কোয়েশ্চেন: level each carbon in the following compound as primary, number 2 secondary, number 3 tertiary, number 4 quaternary. Okay, so what is the structure? The structure is something like this: CH3. আচ্ছা, এরকম ভাবে দেবো না, এরকম ভাবে দেবো। লেটস মেক ইট মোর টাফ। Do it. Shagnik, the first question that I've given is this one. Label each carbon in the following compound as primary, secondary, tertiary, and quaternary. So first of all, answer this question, and after that I'll start today. Quickly complete this and tell me.
স্যার হয়ে গেছে।
হয়ে গেছে? আচ্ছা, তারা
হ্যাঁ
বাকিরা
স্যার।
করুক। বাকিদের রয়েছে? খালি একজন করলে হবে?
স্যার কি বলে করবো
হুম,
কিভাবে মানে
কি করবে কিভাবে বলো, আরেকবার বলো।
করবো কিভাবে মানে মার্ক কি করবো এখানে?
এখানে
আচ্ছা মানে
প্রত্যেকটা কার্বনকে 1 ডিগ্রি না টু
হ্যাঁ,
ডিগ্রি 3 ডিগ্রি না 4 ডিগ্রি,
আচ্ছা
প্রাইমারি, সেকেন্ডারি, টার্সিয়ারি, কোয়াটারনারি,
হুম,
we'll have to mark them, প্রত্যেকটা কার্বন। ঠিক আছে, তো মার্ক করো। হয়ে গেলে বলো। বলো ভালো। ঠিক আছে মানুষ বলো।
হ্যাঁ
Okay,
স্যার।
let's start this. First of all, you'll have to write it like this: CH3, CH2, CH, double bond C, CH3, CH2, CH, CH3, C, triple bond CH. So this is the condensed form of the structure. All right. Now we will mark whichever is 1 degree carbon, 2 degree carbon, 3 degree carbon, 4 degree carbon, one by one. So what about the first one?
স্যার ফার্স্ট ওয়ান প্রাইমারি।
The first one is primary. So this is 1 degree carbon or primary carbon, right? What about the
হ্যাঁ।
second one? It
Two
is a
সেকেন্ড
degree.
ওয়াট হবে
carbon.
সেকেন্ড
Yes. What about the third one? It's a
2 ডিগ্রি
2 degree carbon. What about this one? It's
3
a 3 degree. Okay. Now what about this one? Two
2
degree. What about this one? 1 degree.
3
Ah,
1 ডিগ্রি এটা
this
নিচেরটা 1
one.
উপরেরটা হ্যাঁ।
This one 3 degree. This one 1 degree. Okay. What about this one? 2 degree. What about this one? 1 degree.
1 ডিগ্রি।
So that's how it is done. Very easy. Understood? কে বুঝতে পারলে না বলো?
সেটা বুঝতে পারলাম না।
আগের দিন বুঝিয়েছিলাম 1 ডিগ্রি, 2 ডিগ্রি, 3 ডিগ্রি কার্বন। মনে আছে?
না।
মনে নেই। তুমি পড়েছো আগের দিনের পড়াগুলো? দেখো, একটা কার্বন যদি ডাইরেক্টলি আরেকটা কার্বনের সঙ্গে অ্যাটাচ থাকে তাহলে সেটাকে বলা হয় 1 ডিগ্রি অর প্রাইমারি। ওকে, if a carbon is directly attached with two other carbon atoms, hence the carbon is 2 degree or secondary. If a carbon is directly attached with three other carbon atoms, it is 3 degree. And finally, if a carbon is directly attached with four different carbon atoms, we call it 4 degree. বুঝতে পেরেছো? সন্দীপনকে জিজ্ঞেস করছি।
হ্যাঁ স্যার, বুঝছি বুঝছি।
On the basis of this, I have just written whether it is 1 degree or 2 degree or 3 degree. Okay, there is no 4 degree carbon. Understood? কারো বুঝতে অসুবিধা হয়েছে? ধ্রুব করেছো এটা?
Yes, sir.
Okay. So let's start today's topic, that is the organic reaction mechanism. Organic reaction mechanism. দেখো, organic reaction means it's a reaction like some other types of reaction. If you know the reaction, like there is so many types of reaction, that is a combination reaction, there is decomposition reaction, okay, there is uh, double decomposition reaction, there is displacement reaction. Okay,
Displacement,
there
double
are,
displacement, sir.
huh?
Double displacement.
Yes, there are many more reactions, types of reactions that you have already studied in class 10. Okay, chemical reaction equation was the chapter, the first chapter of your NCRT. So you already know many things about chemical reaction. Okay. Now you don't know anything about organic reaction mechanism, right? The organic compounds, they do react also in a similar sort of manner. Okay, but their reaction is little bit different from the inorganic compounds, right? So in this particular topic, we'll be discussing the reaction mechanism of the organic compounds one by one. So let's discuss. First of all, in an organic reaction, we need two things. One is a substrate, another one is a reagent. All right. So what is a substrate and what is a reagent, that we need to know. Substrate and reagent. Okay. So what is substrate? What is reagent? So basically, let's have an example. See, you are having this one. This is known as alkyl bromide. Particularly in this case, you have a methyl bromide, or in the language of IUPAC, it is bromomethane. So let's write methyl bromide only. Methyl bromide. Okay. Okay. Now you are adding some OH minus with this methyl bromide. What type of OH minus? For example, you take potassium hydroxide KOH. For example, you take KOH, potassium hydroxide, which gives you OH minus. So that OH minus you are using. Okay. So this particular methyl bromide is known as the reagent part. Sorry, substrate part. Substrate. On the other hand, this OH minus is reagent. Basically, the minus charge in this is over the oxygen atom. So it is better to write it like this. All right. Okay. Uh, so what happens? The reaction is just like this. This O center just attacks the carbon center, and this bromine goes out of the system. So as a result, you get something like this. It is quite obvious. In place of Br, you have now this OH, and Br minus goes out of the system. So you know these things are called products. Okay. So the substance, okay, the substance uh, which you treat with a particular attacking agent is called substrate. Okay. And the more reacting substance, or the main substance which is supplying the heteroatom, is basically the reagent. In this case, OH minus is the reagent and methyl bromide is the substrate. So let's take another example so that it becomes more easier. Now, suppose we have this one. This is called benzene. This is called benzene. Okay, and we have added CH3Cl with the benzene. Now, in that case, CH3Cl supplies a methyl group to the benzene. Okay, and as a result, the end product is something like this. This is called toluene. And along with toluene in this reaction, some side product is also formed. Okay, for example, here in this case we take just AlCl3 as a catalyst, and this chlorine and this AlCl3 gets combined and they form AlCl4 minus. This is a side product. So in this case, in this particular case, the benzene is basically the substrate, and this one is the reagent. So basically the reagent attacks the substrate. Are you getting what I'm saying? The reagent attacks the substrate and we get a product, one or two or three or more products. Okay, so this is how a chemical reaction or a organic chemical reaction occurs. Okay, this is obviously not the end, we have to learn more, and we get a product. Okay, a reagent, the basic thing is the reagent attacks the substrate, and, and the product is formed. All right, any doubt?
স্যার এই জায়গাটা আবার বোঝাবা?
কোন জায়গাটা বলো?
মানে এই যে বেনজিন রিএজেন্ট, মানে এই পুরাটাই?
হ্যাঁ, you just see one thing, একটা জিনিস দেখো। अच्छा क्षितिज, समझ में आया या नहीं आया?
স্যার এটা না বুঝিনি।
अच्छा ठीक है, चलो। This you can understand that there are two things, they are reacting with each other and you are getting a product. Up to this, is it clear? Up to this, is it clear? There are two things, okay, they are reacting and we are getting some product, like an ordinary chemical reaction. এটা তো বোঝা যাচ্ছে?
হ্যাঁ স্যার।
ওকে, এইবারে কি হচ্ছে দেখো, there are two things, means there is one reagent and there is one substrate. Okay, now substrate is the main thing, the reagent is a more active thing. A reagent attacks the substrate. Okay, a reagent attacks the substrate and we are getting a product. ভালো করে লক্ষ্য করো, this is a reagent, this is the reagent. This reagent gets attached with the substance. Okay,
হ্যাঁ স্যার।
with the carbon part of the substrate, reagent is attached, the reagent part is attached. Okay, the main thing on which the reaction is happening. For example, in the first case it is methyl bromide. For example, in case of second one it is benzene. Okay, methyl bromide and benzene, these are the main things जिसके ऊपर हम लोग रिएक्शन करवा रहे हैं. ओके, जिसके ऊपर सबस्ट्रेट रिएक्ट, सॉरी, reagent react कर रहा है, that is a substrate. All right, so substrate becomes a product with the reaction with reagent. Okay, on reacting with reagent, the substrate is getting converted into the product. Now what happens during this reaction? During the reaction, bond fission occurs. Okay, now what is a bond fission? See, during this process bond fission occurs. Now what is bond fission? Bond fission means the breaking of bond. Bond fission means the breaking of bond. Okay. Now breaking of bond can be of two types. Suppose you have got rather three types. See, Rx. This is an alkyl halide. Okay. Either this halide group can go out of the system along with the electrons. Hence, the X will become X minus and R will become R plus. So this is a type of fission. Okay, this is another kind of fission. Without the electron, the X goes out and you are getting R minus and X plus. Okay, and there is another type of fission, that is this one. There are two electrons. So one electron is taken away by X, another electron is kept by R. So it is R dot and X dot. So this is how a fission can occur. So there are three ways. Okay, the first two combined is known as heterolytic fission. Heterolytic fission. And the second one is known as homolytic fission. This is basically the processes or the types of bond breaking. Whether the X group can go away along with the electron of this RX bond. So obviously has one more extra electron. So that's why minus charge is over the X. But in case of this R, as it is losing its electron, so it is R plus. Okay. Similarly, in the second one, here this X is going without any electron. So R has all the electrons in this case. So that's why a minus charge is there over the R, and the X is just X plus. Okay. What about a homolytic fission? In a homolytic fission, the X goes out with only one electron, and one electron is there with the R. So this is why it is called a homolytic fission, because they both keep equal number of electron with them. Understood? বোঝা গেল?
Yes, sir.
So this is how a bond fission is done. That means this is how a bond is broken. Okay. Now we will have to learn the types of reagent in organic chemistry. See, this is
Sir,
reagent. Bolo.
স্যার ক্লিভেজ আর ফিশন তো একই না?
Exactly. Same. Okay. These are reagents. These are basically two separate types of reagents. So that's what we will learn. How many types of reagents are there? So types of reagents in organic chemistry. So let's go to the second page. Types of reagent. Types of reagent. See, reagents are of two types. Okay, one is electrophile, another one is nucleophile. So first one is electrophile, the second one is nucleophile. So what is electrophile and what is nucleophile? We will have to learn. So phile stands for affection. Okay, this phile comes from uh, affection. Okay, so electrophile means those species which have affection towards electron. That means the electron loving species, and the nucleophile is The nucleus loving species. अच्छा क्षितिज, मुझे एक बहुत ही सिंपल सा क्वेश्चन का आंसर दो। न्यूक्लियस में क्या रहता है? एक एटम का न्यूक्लियस के अंदर कौन सा पार्टिकल प्रेजेंट है? अनम्यूट करो पहले खुद को। एट फर्स्ट, हाँ बोलो। एक एटम के न्यूक्लियस के अंदर, ओके, कौन सा पार्टिकल रहता है? बहुत ही आसान सा सवाल
ऐसा
पूछा है।
पार्टिकल।
हाँ बोलो। बोलो फिर से बोलो, जरा सुनाई नहीं दिया मुझे।
ऐसा पार्टिकल।
सुनाई नहीं दे रहा है, क्या बोलते पारबे बोलो। व्हाट आर द
शायद
पार्टिकल
प्रोटॉन और
प्रेजेंट
न्यूट्रॉन।
देयर? यस,
प्रोटॉन और न्यूट्रॉन।
exactly. In the nucleus, you have proton and neutron, right?
न्यूट्रॉन।
Now, neutrons do not have any charge. Okay, so the charged particle in the nucleus is only proton, right? Neutrons do not have any charge, so there are only protons which are charged. That is positively charged particle in the nucleus. Fine. Now, a nucleus loving species means those species which will love a positive charge, right? Those which will love a positive charge. That means they are nucleophile. On the other hand, electrophile means those which will like the electron. That means those which will like the negative charge. So the charge of electrophile will be obviously positive. So then only they will like the electrons. So that means electrophile contains a positive charge or lacks electron density, or a nucleophile contains more electron. So it has got more electron density. जिसके पास इलेक्ट्रॉन ज्यादा है वो पॉजिटिव चार्ज को पसंद करेगा, जिसके पास इलेक्ट्रॉन कम है वो नेगेटिव चार्ज को पसंद करेगा। ओके, नाउ इट इज टाइम टू know some examples of electrophile and nucleophile. Okay, nucleophiles पे बाद में आते हैं थोड़े से। Electrophiles basically of two types. One is positively charged, another one is neutral. One is positively charged, another one is neutral. Okay, some example of positively charged electrophile are as follows: H plus, okay, CH3 plus. This is called carbocation. Okay, so these are basically the positively charged electrophile. What about a negatively charged, sorry, neutral electrophile? See, a neutral electrophile are those which are having a vacant orbital. For example, any type of Lewis acid like BF3. Okay, boron has got vacant orbital, so it can take electron. So it is basically electrophile. Next, a carbonyl carbon is an electrophilic center. This carbon is electrophilic center. Okay,
ও
so
স্যার
this is how.
কার্বন এটা কি বললে?
কোনটা বলো?
যে কার্বন, ওই যে কার্বন তারপরে ডাবল বন্ড ও।
This is called carbonyl carbon. I'm writing C double bond O. This is called carbonyl carbon. Okay, carbonyl. aldehyde, ketone, carboxylic acid. In those substances, you have already seen this type of carbon atom, C double bond O. Now, what about nucleophile? Nucleophile can be of two types. One is negatively charged, another one is neutral. Okay, a negatively charged nucleophile, some examples are OH minus, Br minus, N3 minus, there are many more, Cn minus, okay, many more are there. There are some neutral nucleophiles. See, neutral nucleophiles must contain a pair of electron, lone pair of electron basically over them. For example, ammonia, extra electron is there as a lone pair. For example, water, some extra electrons are there as lone pair. So these are the nucleophile. Okay, so the reagents that you can see are only two types of reagents are there, that is electrophile and nucleophile. Electrophile means those species which loves electron, and nucleophile means those species with which love nucleus. So electrophile lacks electron density and nucleophile has more electron density. Okay, electrophile can be of two types, one is positively charged or neutral, and nucleophile can be of two types, one is negatively charged, another one is neutral. Okay, some examples are there. So you can get questions like, give an example of positively charged nucleophile, positively charged electrophile. Okay, sorry, positively charged electrophile only, nucleophile is negatively charged. So, or you might have, suppose in a question paper there is given a list of reagent from which you may have to select whether they are electrophile or nucleophile, or you have to identify. So these type of questions might come in the exam. Okay, let's have an example. Let's have a demo question. uh, just a moment. Categorize the following. Categorize the following molecules ions as nucleophile or electrophile. Nucleophile or electrophile, categorize करना है. The first one is HS minus, the second one is BF3, the third one is C2H5OH, the fourth one is CH3 whole 3N, the fifth one is Cl plus, the sixth one is CH3 C plus, the C plus, not C plus, CH3 C double bond O H, this one. The next one is NH2 minus, and another one is NO2 plus. So একজন একজন করে বলবে. সন্দীপন বলো,
হ্যাঁ
the
স্যার।
first one, electrophile or nucleophile?
স্যার ইলেকট্রোফাইল।
কি করে electrophile হয়? Electrophile means substance which loves electron, that means it
আচ্ছা,
must have
হ্যাঁ
positive charge
হ্যাঁ
density.
এটা
It
নিউক্লিওফাইল। হ্যাঁ
dislikes negative charge because it has got a
হ্যাঁ
minus charge. So that means it is a nucleophile.
হ্যাঁ হ্যাঁ হ্যাঁ।
What about this one? ধ্রুব বলো। একটু আগে বললাম, এটা তো করিয়ে দাও অলরেডি, কমন। এটা ধ্রুব বলবে। ইলেকট্রোফাইল, নিউক্লিওফাইল।
ইলেকট্রোফাইল।
ইলেকট্রোফাইল, ভেরি গুড। আচ্ছা, what about this one, Saloni? What about this for third one, Saloni? थोड़ा कोशिश तो करो। Saloni, unmute your mic and try to answer this. I have given some hint, so answer the question. C2H5OH, which is an alcohol, the name is ethanol. কে বলবে? Ethanol electrophile না nucleophile?
স্যার নিউক্লিওফাইল।
Nucleophile, because there is a presence of lone pair. What about this one? This is called
কয়েকটাও
amine.
নিউক্লিও।
Nucleophile. क्षितिज बोलो
স্যার
Cl
এটা
plus.
নিউক্লিওফাইল কেন হলো এই যে C2H5 OH টা মানে ইথানলটা?
I mean, there is an excess electron density over this oxygen.
আচ্ছা।
Excess electron density over the oxygen,
হুম, হুম, হুম।
like water, like ammonia. Okay. What about Cl plus, Kshitij?
Electrophile.
Electrophile. Very good. What about this carbonyl compound? কে বলবে বলো? সৌভিক. This is a carbonyl compound, and I've already told you carbonyl compound is what? Electrophile or nucleophile?
Sir, electrophile.
Electrophile. সৌভিকই বলো, NH2 মাইনাস এটা কি হবে?
Nucleophile.
খুব সোজা, নিউক্লিওফাইল। শাগনিক বলো NO2 প্লাস। শাগনিক কি বেরিয়ে গেছে? আছে তো। শাগনিক আনমিউট।
স্যার হ্যাঁ স্যার।
হ্যাঁ, NO2 plus, electrophile
স্যার
or nucleophile? It is a
ইলেকট্রোফাইল।
electrophile. Okay, it is a very easy question. Okay, so these type of questions might come. You might be given a list of substances. You'll have to find out which one is an electrophile and which one is a nucleophile. Understood, everyone? Electrophile, nucleophile, have to find out whether it is an electrophile or it is a nucleophile. These things are clear.
স্যার
Anyone having any doubt? Saloni, you are having any doubt in this? সৌম্যদীপের কোনো ডাউট আছে?
না স্যার।
ওকে, চলো, let's move forward. Now we will learn the bonding theory and the electronic factors in organic compound. The next topic that we are going to read is the bonding theory and the electronic factors, okay, of organic compounds. So first of all, we need to discuss 3 points in this topic. The 3 points are: number 1, inductive effect; number 2, resonance; theory. Number 3, hyperconjugation. So these are the three things that we need to learn or we need to understand. Okay, so one by one. So the first one is inductive effect. So what is meant by inductive effect? Let's have a quick discussion. So the first one, that is inductive effect. See what happens. For example, let's take this CH3, CH2, CH2, Cl. Okay, this is a alkyl halide. This is an alkyl halide. Okay, so what we need to understand. See, this carbon is more electropositive. Do you agree? And this chlorine is more electronegative. Anyone who does not agree with this can unmute yourself and tell me. Carbon is more electropositive, and chlorine, which is a halogen element, is more electronegative. Okay. Now this carbon has got a tendency. Tendency of what? This carbon has got a tendency that it pushes the electron density towards the chlorine. Okay. Similarly, the second carbon pushes its electron density towards the first carbon. And the third carbon also pushes its electron density towards the second carbon. So just give the number 1, 2, 3. So as you can see, the carbon atoms, they are pushing the electrons towards the next atom in the compound that I have written. Okay. Now what about the chlorine? Being a more electronegative element, we can also say that this chlorine is dragging the electron density of carbon towards itself. Okay. So two types of factors are there, right? One is the carbon atoms are dragging the electron density, like pushing its electron density towards the other one, and the chlorine, which is a more electronegative element, is dragging the electron density towards itself. Okay, so there is basically a shifting of electron density which is taking place, right? So shifting of electron density, shifting of electron density. So this is basically known as inductive effect. This shifting of electron density is known as inductive effect. Now, this carbon is pushing the electron. So that means this carbon shows a plus I effect or a positive inductive effect. And this chlorine is taking the electron towards itself. So that's why it is a negative inductive effect or minus I effect. In general, inductive effect is represented as I. So the electron donating inductive effect is also known as plus I effect, and the electron withdrawing electron inductive effect is also known as minus I effect. So as you can see, a carbon containing group like any kind of alkyl group like methyl, like ethyl, like propyl butyl, they contain plus I effect. On the other hand, any halogen group like fluorine, like chlorine, like bromine, they show minus I effect. Okay. Now there are many groups which show minus I effect other than these three, and there are many more groups which show plus I effect other than these two that I have shown here. Okay, so now some examples of groups containing minus I effect are as follows, like nitro NO2, okay, like SO3H, like CN, CHO, COOR, okay, any kind of halogen group, like OH, like OR. These groups all contain minus I effect. On the other hand, some groups that contains plus I effect, like COO minus, okay, like O minus, other than this methyl or ethyl, okay. Remember one thing, a hydride group, it does not contain any effect. It does not contain any effect. Understood? বলো, কেউ যদি বুঝতে না পেরে থাকো তাহলে বলো।
Sir, minus H টা কেন does not contain any effect?
আবার বলো, মাইনাস,
Sir, H টা কেন does not, মানে কোনো এফেক্ট নাই কেন এর?
হ্যাঁ, এইচটার এফেক্ট নেই কেন, তার কারণ বলা যেতে পারে। দেখো, এইচ যখন কোনো বন্ডেড অবস্থায় থাকে, ঠিক আছে, এইচ এর নিজের মধ্যে কোনো ইলেকট্রন থাকে না, একটা ইলেকট্রন which is bonded. There is only electron in hydrogen which is bonded. So that's why it is neither electron rich, it is nor electron deficient. So that's why hydrogen do not show any kind of effect, inductive effect. The only group, that is hydride group, okay, or hydrogen group rather, it never shows any kind of inductive effect, neither plus I nor minus I. Okay, some groups show plus I effect, that means they drags the electron towards others, and there is some groups which show minus I effect, that means they drags the electrons from others towards themselves. Okay,
হুম।
তো বুঝতে না পেরে থাকলে বলো, কেউ বুঝতে না পেরে থাকলে বলো।
বুঝেছি স্যার।
Okay, just a moment. Okay, so this was all about inductive effect. Okay, so keep this concept in mind. Using this concept, we are going to explain many things in organic chemistry. Okay, now the most important thing in organic chemistry which you are going to learn is resonance. You have a very little concept of resonance that you got in the chapter of chemical bonding, if I'm not wrong. So in this chapter, you are going to get a vast knowledge of resonance. Okay, so let's have a discussion. The resonance theory. See, what is resonance basically? We have not discussed anything regarding benzene till now, right? So, obviously, as of now, it is not needed. Later on in the next chapter, we will be discussing benzene and the properties of benzene. So, as of now, let's have a look. This is called benzene, or you can also call it 1,3,5. Okay, cyclohexa 1,3,5 triene. All right, cyclohexa, sorry, cyclohex 1,3,5 triene. Okay, see, as you can see, uh, all the bonds are not double bonded, right? All the bonds are not at all double bond. That means
Sir, sir,
this
sir.
bond is a single bond. Bolo.
1, 3 আর 5 কেন?
সেটাই তো, কেন অসুবিধা কোথায়? এই যে 1 নম্বরে ডাবল বন্ড শুরু হলো 1, 3 নম্বরে ডাবল বন্ড শুরু হলো 3,
আচ্ছা,
5 নম্বরে ডাবল বন্ড শুরু হলো
ডাবল বন্ড নাই আছে।
এই জন্য 5. So cyclohex 1,3,5 triene. Okay, now you can also call it benzene. Okay, now as you can see, this bond, that is 2,3 bond, is not a double bond, it's a single bond. This 4,5 bond is not a double bond, it's a single bond. And this 6,1 bond is not a double bond, it's a single bond. Yes or no? এই বন্ডগুলো সিঙ্গেল বন্ড তো,
হ্যাঁ স্যার।
but the studies have shown that all the carbon carbon bonds in benzene are equal. Okay, the studies have shown that all the carbon carbon bonds in benzene are equal. So how can you explain this with this particular structure that we have written over here? It is practically impossible to explain this carbon carbon bond length of benzene, which says that all the carbon carbon bond lengths are equal. Not at all possible. Okay, now to explain this, we draw benzene in a different way, and this is the way. Now you can see the 1,3,5 is no longer 1,3,5. It is 2,4,6, because from the second carbon the double bond is starting, so 2. From the fourth carbon the double bond is starting, so 4. And from the sixth carbon the double bond is starting, so 6. So now it is 2,4,6. Okay, now if you combine these two structures to get a resultant structure like this, okay, which says that all the carbon carbon bonds of benzene are equal in length. Okay, it is also known as the Kekule structure of benzene. Details we will discuss in the next chapter, not here. So this is basically the first structure. This is the second structure. The second structure is obviously known as 2,4,6 triene, and this is called the resonance hybrid. Okay, this is called the resonance hybrid. So that means benzene cannot be written with only one structure. Okay, you have to write it in more than one structure to explain all the properties of benzene. Okay, so these structures are called resonance structures. The structure 1 and structure 2 is known as the resonance structures, and the third one that I have written is the resonance hybrid. Understood?
Sir.
So there are many rules that you need to follow while writing a resonance structures. Okay. Now, what are the rules that you need to follow? The rules are as follows. One by one, I am writing the rules. Rules of resonance. Rules of resonance. First of all, each resonating structure is a Lewis structure of the component it represents. Okay. So, number one, each resonating structure is a Lewis structure of the component it represents. Okay, it is the basically Lewis structure of the component it represents. So, while writing the Lewis structure, you must follow some certain rule. Okay, so what are these rule? Number one, Roman 1, all nuclei would remain in same relative position. That means all the nuclei would remain in the same position. You cannot change the position of any nuclei. Like you cannot, suppose the carbon is there in a particular position, you cannot change the position of the carbon or the oxygen while writing a resonance structure. Okay, the rule of octet has to be followed. The rule of octet has to be followed. We are discussing the Lewis structure or the Lewis concept of bonding, okay, which is based on the law of octet. So the law of octet or rule of octet has to be followed while writing the resonance structure. Okay, next one, the bond angles would be according to the hybridization. The bond angles will be according to the hybridization. Okay, the bond angle will be according to the hybridization. Number 4. Okay, no, number 4 is not needed. Only these you have to keep in mind. Okay, so all the nuclei should remain in the same place. The rule of octet has to be followed. The bond angles will be according to the hybridization. So this you will have to remember while writing a resonance structure. Okay, for example, if you write down the resonance structure of carbon dioxide, say this is the carbon dioxide, carbon, double bond oxygen, double bond oxygen. Okay, now these are the electrons or the electron pairs present over the oxygen of carbon dioxide. All right, so two pairs basically of lone pairs of electrons basically over each oxygen. Okay, so you can also write carbon dioxide in this way, oxygen, single bond carbon, triple bond oxygen. Okay, so with this oxygen you will write a negative charge, and with this oxygen you will write a positive charge. Remember one thing, oxygen with three bonds always have a positive charge over it. Oxygen with A double bond is neutral. Oxygen with a single bond always have a negative charge over it. Similarly, nitrogen with four bonds, rather, yes, four bonds have a positive charge over it. Nitrogen with three bonds have no charge over it. A nitrogen with two bond always have a minus charge over it. This just keep in mind. You will need this concept in organic chemistry so many times. Very, very important concept. Okay, now let's go back to the resonance structures of carbon dioxide. So basically, these are the structures of carbon dioxide. You can also write this in this way: oxygen, triple bond, carbon, single bond, oxygen. So minus charge over this oxygen and plus charge over this oxygen. So these are the resonance structures of carbon dioxide. Okay. So these are the resonance structures of carbon dioxide.
স্যার একটু দাঁড়াও লিখে নিই এটা।
You know.
হ্যাঁ স্যার হয়ে গেছে।
Hmm. Okay. Among them, among these resonance structures, some are more stable, some are obviously less stable. Right. So we are not going to this which one is more stable, which one is less stable. Later on, we'll learn because there are some rules we need to follow. Okay. Uh, Now, what we need to learn is resonance energy. What is resonance energy? Let's have a look. Resonance energy. Okay. So, what is resonance energy? Resonance energy is basically the energy gap. Okay, resonance energy is basically the energy gap between the resonance hybrid and the most stable or the best resonating structure. Okay, so this is basically the energy gap between the best resonating structure and the resonance hybrid. Okay, best resonating structure and the resonance hybrid. Now, contribution of resonating structures. Contribution of resonating structures. Like which one is more contributing or contributory, which one is less contributory, like this. So there are a few rules that you need to follow to understand this. Number one by one I'm writing the rule. Okay, number one, structures with more number of bonds or covalent bonds will contribute more. Structures with more covalent bond will contribute more. Okay, secondly, uncharged structure will contribute more. Uncharged structures will contribute more. Okay, uncharged structures will contribute more than the structure with charge. Okay, next one, structures with unlike charges closer will contribute more than the same, or those with charges apart, than those with charges apart. I'm explaining these things. Next one, structures with like charges closer will contribute less. Okay, structures with positive charge over electropositive atom or negative charge over electronegative atom will contribute more. Okay, next, structures with aromaticity will contribute more. What is aromaticity? We'll learn. Will contribute more. So these are the rules of resonance structures, which is more stable, which is less stable. Okay, now on the basis of that, we'll see some resonance structures and which one is more contributing and which one is less contributing. Okay, so this one, this is called a carbonyl compound. Okay, now there is a resonance structure of this carbonyl compound which is like this. Now can anyone tell me which one is more contributing, first one or the second one, on the basis of the rules that we have just studied? Let me show you the rules
So
and now tell
second,
me. Second, why the second?
was the unlike charges?
Just a moment. What is the first rule that is written? What is the first rule that is written?
Hmm.
Read it louder.
Structures with more covalent bond will contribute more.
So which one is having more number of covalent bonds?
First,
First one. It is quite obvious that the first one is more contributing. Understood?
sir.
There is additional factor, that is there is no charge, it is neutral. That means uncharged. I'm talking about the first one. It has got more covalent bond, it is uncharged, so obviously it is more stable.
Contribute.
More stable. Okay, it contributes more in the structure of the carbonyl compound. What about this one? NMe2. Here is a plus charge. Okay, and the resonance structure is something like this: lone pair over nitrogen. So it is double bond NMe2, Me2, Me. That is methyl methyl. So now in this case, which one is more stable or more contributory? First one or the second one? Okay, bolve. The rule is
Second.
again same. Second one. So it is more stable. The reason is
Ajay,
there
covalent
is
bond.
more number of covalent bond which is present there. Right. What about this one? What about this one? See, this is called furan. Remember the name furan. The resonance structures of furan are something like that. One by one, I am writing the resonance structures. How to write the resonance structures or draw the resonance structures? I will show you. I will teach you. Okay. So this is the first one. Okay. This is the second one. This is the third one. First one, second one, third one, and now this is the fourth one. So one, two, three, four, five. Just comment which one is more contributory, that is more stable. So you cannot stick by the first rule only. You will have to go beyond that in this case. Yes. Which one? But obviously, in the second rule, you will get the answer. What is this? What is the second rule?
Uncharged structures will contribute more.
Uncharged structures are more contributory. So what is the answer?
First.
First one is mostly contributory. Okay. After that, which one will come? Among 2, 3, 4, and 5. So go beyond the second rule and tell me. Unlike charges, what do you mean by unlike charges? The oxygen atom
Opposite.
having a positive charge. Okay, in all the cases, right? The oxygen atom is bearing a positive charge in that case. Okay, so the more electronegative oxygen atom is bearing a positive charge. Okay, I'm coming towards the point of unlike charges. So there is no issue with that. Now, there is another point. See, unlike charges, if they are close, what is unlike charges? Plus minus. They are unlike charges. What are like charges? Plus plus or minus minus. They are like charges. So they are like charges and they are unlike charges. So if the unlike charges are close to each other, they are more stable. So in 2 and 3, the unlike charges are closer. But in sorry, and 3 and 4, the unlike charges are closer. But in 2 and 5, you can see that the unlike charges are a little bit further away. See, in this case, plus and minus further away. In this 5, plus minus, they are far apart from each other. But in case of 3 and 4, these charges are a little bit closer. Can you see this? So 3 and 4, they are stable compared to 2 and 5. But they are equally stable. So maximum stable is 1, followed by 3 and 4, and then 2 and 5. Why I'm giving equal sign? Because these structures are similar. Okay, as you can see, these structures are similar. That means 2 resembles with 5, 3 with 4. So that's why there is an equal sign in between them. So this is the order. Understood?
স্যার।
আন্ডারস্টুড? বুঝতে পারলে না বলো,
স্যার।
যদি কেউ বুঝতে না পেরে থাকো তাহলে আমাকে বলো। বুঝতে পেরেছো? ক্লিয়ার?
স্যার ক্লিয়ার। স্যার এখানে
Tawfiq?
ওই পয়েন্টটা ইউজ হচ্ছে না, স্ট্রাকচারস উইথ আনলাইক চার্জেস ক্লোজার উইল কন্টিনিউ মোর দ্যান দোজ
Yes,
উইথ
yes,
চার্জেস।
yes, yes, yes. Structures with unlike charges. Okay. The structures with unlike charges, they always close to each other. If they are close to each other, that is more stable. If they are further apart, they are less
Hmm.
stable. So that's what I have used over here. বুঝতে পেরেছো সবাই?
হ্যাঁ স্যার।
क्षितिज, समझ में आया?
স্যার
देखो अभी
স্ট্রাকচার অফ
थोड़ा सा।
লাইট চার্জেস হয়,
हाँ बोलो बोलो, आगे बोलो।
স্ট্রাকচার অফ লাইট মানে লাইট চার্জেস হয়,
Structures of,
লাইক চার্জেস, এটা তো আনলাইক চার্জেস হলো না?
হ্যাঁ, like
তো লাইক
charges means, like charges means দুটো প্লাস
পজিটিভ।
চার্জ
হ্যাঁ।
যদি কখনো কখনো কাছাকাছি চলে আসে
হ্যাঁ।
তখন আনস্টেবল। ওকে,
আচ্ছা।
দুটো মাইনাস চার্জ যদি
আচ্ছা।
কাছাকাছি চলে আসে
হ্যাঁ।
আনস্টেবল।
আচ্ছা।
Okay, like charges should remain far apart, but unlike charges should remain closer to each other.
হুম।
Then it will be a stable compound or stable resonance structure. Understood?
Yes, sir.
Next day, that is on Friday, we will try to learn how to draw a resonance structure. Okay, so gradually we will learn everything regarding resonance structure, and alongside that we will also try to learn, we have already learned how to find out which is more contributory, which is less contributory, and next day we will draw resonance structures by our own, and then we will find out which one is more contributory, which one is less contributory. Okay, next day we will finish up this resonance, and there will be another concept, that is hyperconjugation, which is very very important. Okay, and a little bit more things are there in this chapter. This chapter is almost over, but there are more things that you need to learn. Okay, gradually we will learn that as well. So that's it for today. Thank you. Next we will meet on uh, Friday. Okay, thank you
হ্যাঁ
everyone.
স্যার।
Chalo.
Yes, sir.
Thank you, sir.
Thank you.
Thank you, sir. Thank you, sir.